Welcome to Chemistry and the Scientific Method. So, what is science? Science is the systematic study of the structure and behavior of the physical world and its phenomena. This systematic study is really, really important. That is at the heart of what science is. It's a systematic study of the physical world. If we don't approach this investigation of the physical world systematically, we're not doing science, or at least we're not doing it well. So chemistry is one portion of science. So chemistry is the science that deals with the composition, structure, and properties of substances and with the transformations that they undergo. So we have elements, they make up compounds, and those compounds and elements have reactions with one another. This is primarily what chemistry is interested in. We're looking at the interactions between different substances and different mixtures. That is what the heart of chemistry is. So science is not simply a collection of facts. It's not just a fact book where we're going to collect a bunch of facts and name species or something. That's not what science is. But science is a way of investigating the world or answering questions. That is the importance of what science is. Science enables us, it's a set of tools that enables us to look at questions and hopefully come up with an answer by systematically looking at it, so we can show that yes, our answer is the right one, or we think that it's the right one. We're not ever totally sure, but we can be pretty darn sure. So this involves making some observations, some collecting of some data, suggesting a possible explanation, generally making a hypothesis. We perform some experiments to test our explanation, testing our hypothesis, right? These three steps are what make science useful to us. Now, we don't have to do these in this order, but this is the heart of what it means to do science. So you've probably learned about something that we call the scientific method. It may have been presented as a systematic approach designed to answer some question. It may have been presented as more of, here's a set of steps that you go through when you do science, and when you're done with them, then you're done. And that's not really what we do as scientists. We have these sort of three things that we do, but we don't necessarily do them in a particular order. We don't necessarily go through them once and then stop. In fact, if that's what you're doing, then you're probably not being a very good scientist. So, again, it's the same things from the last slide. We make observations, we formulate a hypothesis, we make a guess, and then we perform some experiments to test that hypothesis. And, as we're performing our experiments, we're making some observations. We may revise our guess. We may say, wow, that was a terrible guess. Let's make a new one. We may say, well, that was pretty close, but it needs a little bit of tweaking. And then we test it again. And so it's not just a set of steps that we walk through and then we're done. It's a process, and we have to come back to it over and over again. So now I want to point out a difference between what we call a law or a natural law. A law is a statement describing what happens under certain circumstances. It only says what happens. Like, an example of a law may be, if I let go of two objects, if I drop two objects, they will both fall at the same speed, or at least they will accelerate at the same speed. Any subsequent interactions with air, that may change things. So a feather and a bowling ball dropped in air will not fall at the same speed, but they will accelerate at the same speed in a vacuum. So in the absence of any air friction, any drag on them, the two objects will fall at exactly the same speed. But that's a law. It doesn't say why that is. It only says that it happens. It says what happens. Right? So Newton's law of gravity, law of gravitation, that says that two objects fall at the same speed regardless of their own mass. But a theory, on the other hand, is something different. A theory is a model attempting to explain why something happens. So a model in science is a word that's used to say, essentially, it's a way of simplifying the world. Right? The world is really, really complex, and a model is our way of trying to visualize or explain the way that the world works in a simpler way, a way that is easier to understand. So you may look at, say, a model of an airplane or a car, and it's a very simplistic model. It doesn't necessarily have all the moving, working parts in it, but it lets you see the overall shape of the plane or the car. And it may have a few moving parts that are the more prominent ones. And that's the same sort of thing that a model is doing. A theory is doing the same sort of thing. It's trying to simplify down the world, the universe, into something that's a little bit easier for us to understand. Right? So one example of this is that many people that aren't scientists say, well, evolution is only a theory. Yes, evolution is a theory, but a theory says why something is true. They say, well, it's not a law. No, of course it's not a law, because evolution is trying to explain why we see natural selection, why we see species changing over time. That species change over time, that's a law. But why species change over time, that is a theory. Right? And so there's a big difference between a theory and a law. A law is just saying what happens. A theory is trying to explain why it happens. We can be pretty darn sure that the laws are right, but theories, we're never totally sure. Now, never totally sure just means there is maybe the tiniest inkling that we might be wrong. But that portion that might be wrong may be a very, very small part of it. It might just be, well, it's not completely right, but it's really close. Right? That's what we mean as scientists when we say something is a theory. We don't mean that, well, we don't agree that it's true, or that we don't think it's true. Right? Many theories, scientists generally accept and there's no disagreement on. The theory of evolution, there is very little disagreement on exactly what that means. Certainly the overall theme is very well agreed upon by biologists. So, in the scientific method, we've got our laws and we've got theories, and so we have, our three sort of steps that we do. We make an observation, we make a guess, our hypothesis, we make some prediction, we test that with some experiment, and we go back to the beginning, and we do it again and again and again. And at some point, if what we're doing is trying to see what happens, like two objects fall at the same speed, well, then we can make a law out of that, only using repeated observations. We've tested it over and over and over again with many different objects, in many different places on Earth maybe, and if we get sufficiently advanced, we go to the moon and we test it again, and sure enough, it works. On the other hand, if we're trying to explain why something happens, then we're not making a law, we're making a theory. Right? We're making a model. We're trying to explain why it's happening. Now, explaining why something happens is always going to be harder than explaining or than stating what happens. It's much easier to say, well, two objects fall at the same rate. That's very easy for us to say because we can test a bunch of objects. But explaining why that is takes much more. Now, as of the recording of this video, and I suspect that for a good while afterwards, we have no idea, really, why. We don't have a satisfactory model, a satisfactory theory for why gravity works or how it works. We know what happens, we know the law, but we don't know why it works. So, once we've done a bunch of experiments, we generate a theory, then we make a prediction based on our theory, we experiment, and we go back and modify our theory as needed. So right now, this is where we are. We're still in this loop of fixing the theory of why or how gravity works. And again, I suspect that we'll be there for a long time yet. So, with the scientific method, it's not necessarily about getting things right or, discovering new facts. It's about doing things in a systematic way. And there's nothing wrong in science with doing something wrong. Now, there's something wrong with doing something wrong and not fixing it, not learning from your mistakes. But in science, you should be making mistakes. We expect you to make mistakes, but you should be fixing them. So, that was chemistry and the scientific method.